This is Dr. SRIDHARAN from SNS College of Technology. In this lecture, we are going to see working principle of supercapacitor and their applications. A capacitor is a device that stores electric energy. A supercapacitor is also a capacitor, but its capacitance value is much higher than other capacitors. It stores and releases energy by the reversible desorption and adsorption of ions at the electrode-electrolyte interface. Supercapacitors are made up of two electrodes on electrolyte and porous membrane separator. So it is similar to the battery, but here we are using the nanomaterial based supercapacitors are used to increase the electrode surface area so as to achieve high performance and enhance capacitance. The unique properties of supercapacitors: long cycling time with high cycle efficiency up to 97%. Supercapacitors have capacitance range from 1 microfarad to greater than 10 kilofarad. Supercapacitors have high energy density of up to 10 watts hour per kilogram. There is less potential for pollution in supercapacitors as no heavy metals are used in their development. So recently the many industries are interested to use for the carbon related materials. The charge discharge time of supercapacitors ranges from milliseconds to few seconds. So that's why the many electric vehicle industries are interested to implement this kind of devices for the fast charging. Supercapacitors have high capacitance with lower voltage limits. Working principle of supercapacitors: the supercapacitors operates by storing electrical energy between two electrostatic double layers created by the formation of thin charge layers on the electrode interface. The porous materials or nanomaterials used to cover the metal plates of a supercapacitor are typically carbon in the form of activated charcoal. So recently we are used graphene and CNT. So such kind of the nanoparticles to improve the properties of the supercapacitor. Static electricity, also known as electrostatics, is used to store energy in capacitors. Both positively and negative charged ions are produced in the electrolyte solution between the two plates of the supercapacitor. So here the representation of supercapacitor, its formation of basic concepts: Helmholtz inner layer, Helmholtz outer layer. Generally we call it as electrical double layer. So electrical double layer is very important. The formation in between the two plates while applying the electrolyte. So recently the many research groups are working on the supercapacitor for many other applications, especially for electric vehicles. Advantages and disadvantages. Advantages of supercapacitors: high energy and power density, high performance reliability with higher charging rates. Supercapacitors can easily be connected in series like batteries to provide bigger voltages. Supercapacitors have a high specific power, low resistance, which enables them to produce high load currents. Supercapacitors are developed in small sizes and lightweight, which makes them easily installed in small areas. So the supercapacitors is used for the small devices to the automobile industries. Supercapacitors have longer cycling time as compared to the battery and higher service life. Some of the disadvantages: supercapacitors have high self-discharge rates. It has low voltage limits which demand serial connections to produce high voltage. and highest dielectric absorptions of to of any type of capacitors. Applications of supercapacitors. The supercapacitors are used in hybrid buses in the field of transportations. They combine with the battery to increase battery life and decrease the size. So the EV industry is nowadays facing the many challenges. That is charging and weight of the battery. So this kind of thing is rectified by using the supercapacitors. Memory devices in laptops, smartphones, tablet are developed using the supercapacitors. These are also used in the LED flash units, and supercapacitors are even used in the field of renewable energy, such as wind energy, to supply power to the pitch control of blades, and also many industrial applications, military, medical, and transportations, etc. Thank you.